What I'm going to start with today is a general form. We call it a core concept. So it's very abstract. Okay, so if you don't get it, don't worry about it. I'll give lots of other examples. Okay, here we go. Here is, today is the 20th. And here is my core concept. And then we'll do the examples. Okay, if we start with a table where we have x's that go 0, 1, 2, 3, 4, and our y's are some other number where we have a subscript 0, so A0, A1, A2, A3, and A4. I know those look funny, but they're just saying when x is 4, they're the y value. Okay? So, if A1 divided by A0 equals R, A2 over A1 equals R, notice that they're the same, A3 over A2 equals R, and A4 over A3 equals R, it is exponential.
What's R?
R is that rate. It's the difference between the quotient of the numbers as we go down. Okay, if they're all the same, it's exponential. So they have a common ratio. And we call that a n plus 1 over a to the n equals r. Okay, so then our equation will be y equals a sub 0 times r to the x. Okay, so this y value right here times this r to the x would be our equation. Okay, so now we're going to do an example. This is just our abstract core concept.
What is n?
N is a number, or it's raised to that power. Okay, it is abstract because sometimes that helps when you're going back, being like, what was it I was doing? Okay, and this is important because in further up in math, you're going to be given just abstract how to do it, and then you have to complete an example based on it. Okay? All right, so we're going to start with a table that has actual numbers. Okay? We've got x and y. So let's say you were given this problem. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. And when x is 4, y is 16. So let's say you saw this and you had no idea what kind of problem it is. How do I know it's not linear? Yes, Michelle?
It's not going up by the same amount every time.
The first difference is not the same. How do we know it's not quadratic?
The second difference is.
Second difference is the same. Third difference isn't the same. It's not a cubic. Fourth difference isn't the same. So this doesn't really make sense. So then I think, okay, maybe it's exponential. So to figure out exponential, we don't do differences. We don't subtract. We're doing quotients. We divide. So I'm going to take a sub 1, which is 2, over 1, and I get 2. So is that my r? Well, let's see if all the rest are the same. 4 divided by 2, does that give me 2? 8 divided by 4, does that give me 2? What about 16 divided by 8? What's that give me, guys? 2. So they all give me 2. So I know my r equals 2. Do I know what a sub 0 is? When x is 0, do I know the y?
Yeah.
What is it? So y equals 1 times, what's r? To the x. That's it. So I'm going to say this again. You should not have your headphones in or your phone on. And you should be writing down what I'm writing down.
So what if you have like a graph like on the homework?
So I'm going to do a couple more tables, and then I will do a graph, Nolan, don't worry. Okay, number 2, I'm going to have you guys figure this one out on your own. Are you ready? Here's my table. I've got X's and Y's. Now remember, you're putting it in the form y equals a sub 0 times r to the x. Okay, you guys try it right now. Okay, what did you guys get? Y equals 1 times 3 to the x. Good. Let's try one more where you guys try it on your own. Ready? We've got when x is 0, y is 2. When x is 1, y is 6. When x is 2, y is 18. And when x is 3, y is 54. Hey guys, what'd you get? Y equals 2 times 3 to the x. Good. Okay, next we're going to try a graph.
I have a question.
Yes.
So 0, x is 0 and y is 2. That means that it would be a 1 over 2 instead of a 1 over 1.
No. You can still do 6 divided by 2. And
Yeah, that's what I'm saying.
if say it again.
Like on the other page, you did like on the personal, it was a with subscript of 1 or whatever
Right.
over 1, and
Yeah.
but on this page it would be 6 over 2.
Yeah.
Okay.
Okay. we need to find the equation of this graph. So the first thing I do is make a table. At 0, x is 0, y is 1. At 1, x is 6. So, first, I found my r. Oop. What is wrong with my statement? What did I mess up on, guys? When x is 0, what is y? It's definitely not 1. It's what? 2.
Oh.
Okay. So I'm going to go 6 divided by 2 gives me, and that's my r. So y equals what? 2 times 3 to the, okay. All right, I have another question to ask you about this.
Is this the one in the classroom?
Similar to it, it's not the same. Okay, what is the domain? What could the x's possibly be? Is there any limit on the x's?
No.
No, they're all real. What about the range? What about the y values? Y has to be greater than 0. It will never reach 0. Okay, last one. So we're taking this problem above, and we're finding the rate of change between, this is not an x and y, we're taking the rate of change between 0 and 3. So this looks like this is x and this is y. It's not. They're both x's. I want to find the rate of change between these two. So for the equation, y equals 2 times 3 to the x. So what's the first thing we should do? How about we figure out what the y's are at those points? So what is 0, 3 to the 0 power times 2? 2. What is 3 to the 3rd power times 2? 3 times 3 is 9 times 3 is 27. 27 times 2 is
I should have known
54. Okay. Now, how do we find rate of change in a linear problem? We find the what? Slope. So you're just making this x1, x2, y1, y2, and you're finding the slope. You're literally going 54 minus 2 over 3 minus 0. And what do we get? 52 over 3? That's it. That's the rate of change. Done. So that should be pretty easy because it's already something you do. It's just slope. Okay. That is it for your notes. You need to do your in-class work first. And then you can do the homework.
Did we get credit yesterday for doing that computer work?
It's like required by state law.
Why didn't we see you?
Because I was in a meeting all hour.
They thought you were skipping.